Like I just walked out of nowhere. I was like,
Okay,
I don't like
focus.
She's like, I
So
don't care.
let's take a look at notes 2.3. He's got a lot of just kind of general information here. So you know that we have linear, quadratic, and exponential functions. And you know, because of our BFF work, that those are the general shapes of those things. Exponential functions, he says, are some of the most important functions in the real world. They happen in nature all the time. When you study populations, when you look at your money in the bank, when you look at elements in their radioactive decay, it's all over the place. So they're really, really important. The general form of an exponential, they kind of talked about this yesterday, is y equals, or f of x equals, a times b to the x. Always, always, always in an exponential, this number right here has to be bigger than 0. In a geometric sequence, your ratio can be negative. Remember, geometric sequences are tied to exponential functions, but this is a big difference between them. In a sequence, you can flip back and forth. That would be okay. That's a geometric sequence and the ratio is -2. You could not write a corresponding function for that because exponentials, b has to be bigger than 0. It has to be positive. Okay, we clear on that? A can be anything. A can be negative. But b will always be positive. All right. If that number is bigger than 1, so in other words, you have something like 2 times 3 to the x, obviously the outputs are going to be growing, right? You're timesing by 3. So if your b is bigger than 1, it's an example of exponential growth. It's like the checkers on the checkerboard. Bigger, 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 bigger. If your base is somewhere between 0 and 1, then we're still exponential, but we won't be getting bigger, we'll be getting smaller because we're multiplying by something like 1/2. So this would be an example of exponential decay. Your BFF that you memorized was e to the x. So your base was e, which is 2.7. So that was growth. You have exactly the same idea, but if it's decay, it looks like that. They get smaller and smaller and smaller. A in the equation represents your initial amount. A is the initial amount. It's like the y-intercept. Think about this equation right here. If I let x be 0, what does this equal? If
2.
X is 0,
1,
2. So the point would be 0, 2. That is called your initial value. In real life problems, X is something like time. So that would be at the moment you made the deposit, or whatever the problem is. At the beginning of the count of the population, whatever it was. B, in the function, B represents the common base that would be present in a geometric progression. It is the ratio in the geometric progression. It's called the common base. Exponential functions, because of the way they look, are always either increasing or decreasing, always. They're always either concave up, or if they're upside down, if we turn one upside down, it would be concave down. What would turn it upside down? A negative A? A negative A value? would turn it upside down. That's what negatives out in front do, turn you upside down. And for exponentials, the end behavior, one side of it will always either be positive infinity or negative infinity. It's always going to be shooting up or down on one side. And then what's it always going to be doing on the other side? Approaching its asymptote. So one side of an exponential is going to approach its asymptote. The other side is going to shoot up or down depending on the direction of the curve. Always, always, always. All right, let's practice. Example 1. Take a look at the picture and write the limit statements for the end behavior. So remember, that's limit as x approaches negative infinity and x approaches positive infinity. So what do you think on the left? 0, and I'm going to go ahead and say from the top, because that is coming in from the top. That's on top of the asymptote. And how about the right? What's happening on the right? Positive infinity. Yep. How about the second one? The second one is an exponential, but it's been turned upside down. That's okay. You have a picture. What is happening as we go to the left? Left is negative infinity, down. And how about to the right? 0 from the bottom, right? We're coming up to 0 from the bottom. Now the next one is a little trickier because they don't give you the picture. You got to think about it based on what you know. So tell me what you think this picture is going to look like. First of all, it's not upside down, right? So it's all going to be up here. Is it growth or decay? Decay. So it's going to look like this. Would that be okay with everybody? So the limit as x approaches negative infinity is infinity, and the limit, that's supposed to be a g, as x approaches positive infinity, 0 from the top.
Do they always approach 0?
No, because they always approach their asymptote. But if we took something like this and put a +2 on the end, Alex, what's that going to do? Move it up 2. So now that asymptote's going to be a 2.
Okay.
Right? So it's always going to approach its asymptote. If there is nothing, if there's no vertical translation, then yeah, it'll be 0. But we can move these things around just like other things. All right, example 2. For each of the following, determine if it's increasing, decreasing, concave, up, or down. All right, so what do you think about A? Concave, which way?
Up.
Up. Increasing or decreasing?
Decrease.
Decreasing. I think those are pretty easy, right? Tell me, you think those are kind of easy? All right, how about the next one? Concave, up or down? Down. And it is also decreasing. Now, the next one is another one where they don't give you the picture, so you kind of have to figure out what does that look like. 3 times 4 to the x. Okay, I don't have anything negative to worry about, right? So it's either going to be going growth or decay. Which one is this one? Growth, because that number is bigger than 1. And if we're growing, we want to know concave up or down. That is concave up, and it is increasing. Are you like, wow, this is easy? I hope so. All right, figure out number 3. Selected values are shown, determine if it could be linear, quadratic, exponential, or none. So I hope what you're doing is first of all checking out the x's. What's happening to the x's? Going up by 5. Okay, good. All good over there. And then find your differences. What are the differences of the y's? I got, for my differences, I got 2, 4, 8, and 16 for my differences. If this thing was gonna be linear, those would all be 2s or something. If it were gonna be quadratic, if I went from 2 to 4, then I would have to go from 4 to 6. But I didn't. I'm not adding anything here. I am multiplying by 2, so that's exponential. Everybody okay with that? All right. Flip over the next page and do the check your understanding. And then I'm gonna give you a worksheet to look at, or actual worksheet to look at. Sounds like our checker problem there, number 1, right? So the first job and the second job, third job, and so on. Does that look good to everybody? So how much money would I make on the third job? This was the first job, second job, third job, 4 cents. Write a rule. What kind of sequence is this? Geometric. So the nth term, I need a rule for the nth term. The nth term will be 1 times 2 to the n minus first. Now there are other equations that could be written that would express the same thing, but that's probably the easiest because that's our formula.
It would get pretty big pretty fast if you were to go for dollars instead of cents. Could you make it like 0.01?
Absolutely, you can. Absolutely. And I'll do that in the next problem because now it says, now I want to make $1 million. So I'm going to think of that as 0.01, 0.02, 0.04, because now my sequence is in dollars. And I need to know which term, now I made my first term 0.01, so which term is $1 million? That makes sense to you? Now how in the heck are we gonna do that? We've got options. How do you think we're gonna do it? Alex?
You do the graph or use blocks.
Exactly. So one thing we could do, either way, it's gonna require a calculator, right? So you're gonna have to pick, unless the directions say you must do this, you're gonna pick. So one option would be to put this in as one equation. By the way, what's that equation gonna look like when you graph it? Exponential growth, right? And then put in $1 million as your other equation, and that will be a line. And then you'll figure out where they cross. Would everyone agree that would be one strategy? Okay. Now, Alex said that it's possible to solve this equation without graphing. Alright, I'll stop talking. You go ahead and graph it and tell me what you come up with. We'll do that first.
would start 28.
I got X to be 27.575, which would mean that that's what X would be, that's what my N would be to equal 1,000,000. So if I want it to be more than 1,000,000, I'm gonna have to do 28 jobs.
Valid deal.
Okay, everybody okay with that? Alright, now, we all good? Alright, now pay attention because some of you might not remember what Alex was talking about. Alex said I can solve this equation without graphing. Now, sometimes that's super easy. So for example, if we had something like 3 times 2 to the x equals 24, that would be easy. I would divide by 3, 2 to the x equals 8, and x would have to be 3. That's called getting a common base. 8 is 2 cubed. You're not going to do that in this problem. So if you're not going to graph an exponential and there's no common base, the only way to solve one is to use logarithms. So okay, let's go back through that process. We'll spend more time on it in this unit also, but let's get this out of the way. What is the step 1 if I am going to solve this with logarithms? Divide. You've got to divide this. This has got to go. So 2 to the n minus 1 is going to equal whatever 1,000,000 divided by 0.01 is. There's 1,000,000, 2 more zeros. Did you get 100 million? Okay, now what? Log both sides? So we're gonna either, and you can do whatever you want, you can LOG or you can LN. It makes no difference, it's the same amount of work, same number of steps. So if I LOG both sides, anybody remember what happens to that exponent when I put a logarithm in front of that? It comes out in front. This is the beauty of logarithms. This is one of the coolest things ever. So out comes the n minus 1 log 2 equals the log of that number, which I think is 1, 2, 3, 4, 5, 6. I think it's 8. Just happens to be 8 if I use basic n logarithms. Just someone double check that. I think that's right.
There's like 8 with a lot of decimals. Wait.
You got
It's just 8.
It's 8.
Remember, your calculator has round off because of all the operations it does. It's just 8. Now I'm solving for n. So could I divide both sides by log 2? Log 2 is a number. Can I divide both sides by log 2? And then, whatever that is, add 1 to it. And it better be that right there. Is it?
Yeah.
And it shouldn't be off at all. I mean, it should be exactly the same thing. Isn't that amazing? We don't want this.
Is it fine if I just did, like, use log base, like on my
Yep.
calculator?
Yep.
Can't figure out how to graph on. Well, you won't get that.
Yeah, play with your window until you see what you need to see.
No, like the X max window, or is he like not even 100, like 50?
It just says invalid DI.
Okay, you have something in there. Let's turn the clock off. That's probably on. Just turn the clocks off. Usually that works.
last year. I would remember algebra 1 for me was an 8th
Okay.
grade. Would have been
All right, next. Identify the following scenarios as exponential growth, decay, or neither. Give a reason for your answer. You buy a car that loses 20% of its value every year. Exponential decay. What are you multiplying by? Every year you're gonna multiply by what? And if you say 0.2, I'm gonna come unglued. 0.8. You multiply every year by 0.8. So you take 0.8 and then times 0.8 and times 0.8. So every year we're going down by a factor of 0.8. All right, restaurant job shares 3% for each shift with its employees. Now stop a minute. Are they increasing what they share each time? So I want you to stop think. If I buy a car, I paid X dollars for it, and then next year it's worth 80% of that, right? And then next year it's worth 80% of that. So I just keep timesing by 0.8, right? What's happening in this problem? I work first shift. I don't know, there's $100, I get 3% of that, right? You work second shift, there's $200, you get 3% of that. You work third shift, there's only $20, you get 3% of that. Am I building on something or shrinking on something? No, because every shift, the base amount is something randomly different. This is not exponential. It's bouncing all over the place depending on how much money is brought in for that particular shift. Right? You see the difference?
So it's neither.
Neither. Yep, it's not exponential. Battery life decreases by 10% every hour. Exponential decay. Whatever you have right now, in an hour you're gonna have 10% less, and an hour you're gonna have 10% less than that. Takes that same number and keeps going down. You deposit money into an account that pays 4% each quarter. That's exponential growth. What am I multiplying by? And if you say 4%, 0.04, I will come unglued. 1.04. I'm multiplying by 1.04. Remember, the money in your bank, hopefully, is growing, right? What happens if you multiply by 0.04? That would be decay. We want growth. 1.04. All right, number 3. See if you can figure out which of those equations describe the exponential growth of rats. Yeah. All right, which one? Pick out the one you think is going to work. All right, I heard a B. I heard somebody say B. I heard a C.
No, B. 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 C. B. What?
Okay, if you said A, you need to be publicly humiliated.
You're a fool.
Because
You're a fool.
A is what kind of an equation? Linear. Guys, come on. MX plus B, that's linear. How about D? You don't say D, because D is quadratic.
D is foolish.
So it's either B or C. They both start, their initial value is 20. Right?
Yeah.
We just got to decide what are we multiplying by. We went from 20 to 25. What are we multiplying by? That's easy. 25 over 20. What does that reduce to? 5/4? Our ratio is 1.25. We multiplied by 1.25. So the answer is B. Got it? All right, now we're going to have some fun.
we have 2.4 now, or no?
Nope,
Oh,
nope.
Yeah.
Gonna do,
massive.
and this one, I had to run off in color.
Absolutely. Calc is short for calc. Calc is short for calculator.
I'm using slang.
Oh.
I'm using slang.
Chat, calc is short for calculator.
Siggy style.
Alright, so
Right,
2.4
well,
is on Friday, folks.
Calc is short for calculator. I'm using slang.
Thank you.
Alright, so let's take a look at what we've got here. Alright, this is an interesting exercise. I remember doing this last year. Okay, so we've got 5 different equations drawn. And your job is to figure out which equation is which. And then you gotta start figuring out what the unknowns are. So in other words, what's the value of A? What's the value of B? And so on. You have to figure all those out. Okay, so let's start with labeling the graphs W, G, H, I, J, and K. So does anybody have a thought on any of them? Identify them by color, so we know which one you're talking about.
G of X has to be blue because it's linear.
Blue is G, and not, there's actually 2 linear ones.
Oh, is
Blue and red are both linear, aren't they?
Yeah.
But we know, you're right, we know that blue is G because it has a y-intercept of 18, and J has a, oh wait, I don't know what J's y-intercept is, I might need to figure that out. Yeah, I might need to figure that
Nothing's
out.
decided.
J has a positive.
Or we can find this.
Yeah, it's going
Well,
up
we
by
know
3.
that's 18
Well, yeah,
because
G,
that's
G
2.
has a or J
Well,
has
yeah,
a
what about that
positive
red?
slope, and whatever G is, it has a negative slope. So red has to be J, and blue has to be G.
Wait, how do we know that G is negative slope?
Look at the line.
That 0.28.
You only have 2 lines. The red one has a positive slope.
But like, how do we know?
Wait,
This
then
is a
Miss Ford,
positive
can't we figure out
slope.
that G equals -5?
Yeah, but
Okay,
how do we
we're not there
know?
yet.
So how do we know that
You
this
know
one's
that
negative?
y-intercept.
Okay, there's only two of these equations are lines.
Oh,
That's-
because like
this
this
is
one's
where it
definitely
is.
positive, so this
So
Yeah.
one's
18 is not gonna be down here with
process of elimination.
the
Okay,
red one, right?
now, what about the curves, the exponentials? Well, notice that green and black are growth, and purple is a decay. If you look at W and K, aren't they growth?
Yeah.
Which means H must be purple.
Yup.
Because you have 2 growths and a decay, and W and K are both growths. So H has to be the decay. Now, which one is which? For the green and the black.
The green one's K.
W is black and the green one is K. Because K has a bigger base, so therefore it is growing faster. Everybody agree? Okay. Now order the following from least to greatest. So at 1, so imagine a line, a vertical line where x is 1. The lowest y value will be green. And the next one will be black. And then red, and then purple, and then blue. Does that make sense to you? We're just going straight up, where x is 1. And we're looking at the y values, and x is 1. All right, now, we're gonna do when x is 100. Obviously, that's not on your picture. That's going out, right? tell me which is gonna be the smallest.
G.
Will it be G? And then the next one will be H. Remember, what is H doing? He's heading down to that asymptote, right? He's going down to 0. J is shooting up. W is shooting up. And K is shooting up fastest of all. You okay with that? Find K of 15 over K of 13. Okay, now wait a minute. What is K? K is F times 3 to the X. So K of 15 would be F times 3 to the 15th. And K of 13 would be F times 3 to the 13th. What happens to the F's? Gone. What happens here? 3 to the 15th over 3 to the 13th is going to be 3 squared, which is 9. So easy. They look so hard, but they're so easy. All right, what's J? J is E plus 3x, that's J. So we want to know J of 15. All right, so J of 15 would be E plus 45. And then we want to know J of 13, which would be E plus 39. So what happens when we subtract this one minus this one? So take this one minus this one. What are you gonna end up with? 6. Now, the moment you've been waiting for. Now you have to find A, B, C, D, E, and F. And I know Helen already has an idea about one of them. You may have an idea about them. Let's see what you can come up with. We'll regroup here in a second. Let's see what you can come up with.
I only thought 2 of them so far.
And while you're working on that, I'm gonna hand out one more paper for you. We're not gonna do anything with this today. I just wanna get it in your possession.
Log in, Max.
Wait, do we have a quiz soon?
We'll be having a quiz soon, yeah. 2 under 2, 3.
Oh, that's not that bad.
Okay, we did that already. Kellen, I think this is the one you were talking about.
Yeah.
As I'm just writing these things down, this one struck me as being pretty easy. This is the equation, and I know it contains the point 2 comma 8. So if I put in 8 for my y and 2 for my x, then it looks like b has to be negative 5.
Yeah.
All right, so you got that one, okay. Can I do something similar here? 8 equals e plus 3 times 2. Did you get e to be 2? This was equation J. So 8 goes in for y and 2 goes in for x. I got e is 2. And then I have k. I can do that here too. Did you get 8/9 for f? I think I can do that here too. Did you get a to be also 2?
Yeah.
Yeah.
All right, so that leaves me with this. You may have a thought on that. Alex, what do you think?
Well, C is the initial value, and that must be 18 since it intersects with line H.
Are you listening to him?
Yeah.
Remember, the initial value of the exponential is the y-intercept. That is what you get when you put in 0. And he said, since the purple and the blue intersect at their y-intercept, and I already know that's 18, then I know C has to be 18. Then I can plug in my 8 and my 2. And it looks like D is 2/3 if I did my arithmetic correctly. You all right with that? Okay, I'm gonna pass back your last quizzes. We've got till, got 8 minutes to look them over, so we'll do that.
Stop.
Remember, I did quite these back up, so do not take them with you.
I got one back grade over testing here over the weekend.
Please talk it over with your partner. Please, don't just sit there.
Mine is 0.
Looking it over.
I already know my mistake. Gus.
Dude, I didn't
Exact same,
I did
I
not do
bet.
this how you do a giraffe.
I bet we have the exact same mistake.
Oh, she hasn't that.
Hey,
The
man,
quizzes.
I didn't know if I just drew Harold.
Who's Harold?
I don't know.
Mine is 2.
She did not find
She
it
did
funny.
not like Harold.
Minus 2.
I guarantee I'm gonna be mad at
Oh, damn.
I like 6 points off just because I didn't write the units. Unit. Easy. Dude, I thought it
Guys, whenever you
Stop.
draw something, whenever your job is to
The
draw
entire
something,
class he's been looking at me doing.
be sure that your axes are labeled. Your picture is meaningless without some kind of reference. So, especially when it's not on a grid, you need to,
That was a mistake.
Anytime.
Dude, I could
all right, go ahead and start looking them over with each other. Figuring out,
How I say
I have never seen such good multiple choice. Most of you got all the multiple